Welcome to Biology My Passion. I am Soumya Harikrishna. We are learning the chapter Excretory Products and their Elimination. Today we will discuss countercurrent mechanism or countercurrent multiplier. Countercurrent mechanism. Mammals have the ability to release concentrated form of urine. We saw a large amount of water is there in the filtrate, but we reabsorb 99% of the content to secrete out only or excrete out only concentrated form of urine. So how can we concentrate this urine? This is mainly done with the help of our loop of Henle and the blood vessel which is running parallel to it, that is called a vasa recta. So it is a branch of the blood vessel which is running parallel to this. So I am drawing like this. This is the vasa recta. Okay. Now we know that this part, that is the Bowman's capsule, PCT, DCT, all these are lying in the cortical region. So you can see here, whereas this part is in the medulla region. That is, the loop of Henle is in the medulla region. Now, behind this, that is, this is a nephron. It is not floating in the air, right? Behind this, the kidney cells are there. That is, this part has the cortical cells, this part has the medullary cells. These cells are called the interstitial cells. So here, cortical cells are there. This part we call it as medullary interstitial cells because they are the cells of the medulla. Okay. But here it is very salty. This medullary interstitium is very salty. Because of that, the urine also will become concentrated. So how it is the concentration increasing, or how is it becoming salty? In the cortical region, the osmolarity is only 300 milliosmol per liter. But I am talking about the interstitial cells. Then it increases 600, 900. By the time it comes to the inner interstitial space, that it becomes 1200 milliosmol per liter. That means highly concentrated form it is happening. So this concentration gradient is needed for concentration of urine. This is maintained mainly by two loops. One is loop of Henle, second is vasa recta. Remember, loop of Henle is a part of nephron, vasa recta is a part of blood vessel, okay, peritubular capillaries. Now we have two limbs of this. This is called the, which limb? This is the descending limb because it is coming down. So the filtrate from the PCT is flowing down in this, right? This is the ascending limb. Ascending means what? The filtrate is now moving up in this. Okay, so the name of this process is counter current multiplier or counter current mechanism we say. Counter means what? Opposite. Current means flow. Flow of electrons is called the electric current. We learned. So flow means a current. So here it is counter current, means in the descending it is downward, ascending it is upward. So these two are in counter current. Understood? Now, coming to this is the descending limb of the blood vessel. This is the ascending limb of the blood vessel called the vasa recta. So here blood is flowing downwards, and then in this ascending limb it is going upwards. So here again this is coming downwards, this is going upwards. So the flow of blood in two limbs of the vasa recta are also counter current. The flow of filtrate in the loop of Henle is counter current. Flow of blood in the limbs of vasa recta is also counter current. Now look at these two. The ascending limb of the loop of Henle, which is in close proximity or which is near the descending limb of the vasa recta, they are in counter current. Here filtrate is going up, here blood is coming down. So these two are also opposite direction counter current. The same way, descending limb of loop of Henle and ascending limb of vasa recta, which are close together, they are also counter current. So everywhere the opposite flow, this helps in the concentration of urine. Now let's see what is happening when the filtrate is coming down. We learned the 65 to 80% of the substances from the filtrate have been taken back or reabsorbed, and a few things have been secreted, that is H plus, K plus and ammonium ions. As a result, what happens, since majority of the things have been taken back, it became dilute. Okay, so that's why it is only 300, here also it will be 300. But when it comes down, it will come down through the descending limb. But the descending limb is permeable to water. That means it will allow water to move out. So water comes out. So when from a tubule, water goes out, naturally its concentration increases, because here, though it is allowing water to go out, the electrolytes or sodium ions are not allowed to move out. So the concentration of sodium, which is acting as a solute, will increase as it comes down. Only water is moving out. So it is becoming highly concentrated towards the end. That is almost 1200 milliosmolarity is there. It is already there in the interstitium. Now when it is going up, the opposite happens. The tube will allow sodium to go out. Chloride also will be actively going out, but here sodium also going out actively. Why? Because interstitium is already salty, so there is a tendency water to go inside, but here we need the sodium to come out because we want the urine to be again dilute. But how can we make it dilute? Now this wall is impermeable to water but permeable to sodium. So the only way is, so water is not coming out, so at least we can take out the solute so that it will become dilute. So the solute is actively taken. So this actively means what? By spending ATP, it is taken out. So this will come to the DCT, again it is in the dilute form. Okay. Now simultaneously what is happening? So understood, descending limb of descending limb of loop of Henle is permeable to water but impermeable to sodium ions. As a result, it becomes filtrate becomes concentrated, but once it goes up in the ascending limb, it is impermeable to water but permeable to sodium. So sodium actively taken out, so it becomes dilute again by the time it reaches DCT. Okay. Now, when it is, we are talking about the vasa recta, so the descending limb of vasa recta will take up all the sodium ions which are sent out from the loop of Henle, ascending limb of loop of Henle, and it will release it here into the near the descending limb of the loop of Henle, or from the ascending limb of the vasa recta it comes out, sodium comes out here. Okay, so here sodium is given out, that sodium is taken by the vasa recta and it is released out again here. Okay, so this is what is happening at this region. Now you must be wondering why this is happening, because it is giving out sodium and that sodium is taken by this and it is brought here, right? So there is a reason for that. Why? Because though we told the water will come out, because we need to make it concentrated as it moves towards the inner side. So water, though it can come out, it is permeable, but water will come out only when there is a concentration gradient, because it is passive movement. So when there is outside is hypertonic, water will move out. So the sodium is brought here so that the outer part becomes means highly concentrated. As a result, water will flow out from the high concentration to its lower concentration passively. That is the reason why the sodium is taken and brought back here. That is usually a confusion for many of us why this is happening here. So as a result, the medullary interstitium, the concentration is kept same. That is towards the inside it is highly salty, and when the filtrate is going back it is becoming again dilute here when it is passing through the DCT. But we know that DCT does not have much reabsorption happening, only some secretion is happening. So and then it comes into the collecting duct. Now from collecting duct also we need to take out a lot of water or reabsorb a lot of water. Here in the collecting duct water comes out, because I told here this part is very salty, so water comes out. Okay. And as a result, towards the end of the collecting duct, what will happen? It is becoming highly concentrated urine. And followed by this, who will also come out? Some amount of urea, because for water to come out, this part also should be highly concentrated. So urea also will be coming out, but we know urea is the waste which we need to excrete out, but here only some amount of urea just to maintain the osmolarity of the interstitium, because when more water comes out it becomes a dilute, right? That should not happen. So for that urea also will be coming out, but this urea, after this excess urea will be taken back by the ascending limb of the vasa recta. Loop of Henle, ascending limb of the loop of Henle. The urea will go to the DCT, then come to the collecting duct, again come out here. So some amount of urea is totally being circulated. So this part, the osmolarity of the medullary interstitium is done by urea, here it is by sodium. So mainly two ions are playing a major role, or two salts are playing major role in countercurrent mechanism, that is the urea and sodium. So now at the end of the collecting that, we get highly concentrated form of urine because maximum water has come out. So here it is 1200. So initially it was 300, now it is 1200. So how many times the concentration increased? 4 times. A very important question. Human beings or mammals have the ability to concentrate their urine dash times. 4 times, very important. 300 to 1200 means 4 times, right? So that's a very important concept to be understood. So here first you have to tell this is for concentration of urine. Then you have to tell that this counter current, which are the counter currents, you have to explain. Then you tell what's happening in the descending limb, what is happening in the ascending limb. Then it is sodium is taken by descending limb and released here for maintaining the osmolarity. When it comes here, water will come out, urea will come out, urea will enter into the ascending limb, again it is circulated here. And mainly this is done by urea and sodium, and 4 times concentrated urine is formed. Hope you like all the lessons I teach. If you find it useful, please share with all your friends, give it a like, and if you haven't subscribed to my channel, please subscribe. Thank you for watching Biology My Passion.